In this video, I would like to show how we would calculate the bond value. It is the same thing as asking how much money would a company or the government that issues a bond would be able to borrow from the investor that would be buying that bond. So selling a bond is the same thing as borrowing money, and you borrow the amount of money that is the price at which you're selling each bond. So if somebody buys a bond from a company or the government, then the price that was paid is the amount that was lent to the company or the government. So how would we find the value of a bond, or in other words, how much one bond would be selling for? Well, the price should reflect how much the investor would be getting back on such quote-unquote loan given to the company or the government, right? So in other words, we need to look at all future cash flows that a company would be paying back to the investor on the loan, on the bond, and discount them appropriately to find their combined present value. So let's calculate the value of a corporate bond which has the following characteristics: 10 years to maturity, $1,000 face value, 8% coupon rate, and 11% yield to maturity. First, the 8% coupon rate and the 11% yield to maturity tell us that because the coupon rate, 8%, is less than the yield to maturity, which is our discount rate, which is 11%. This means that the bond value should be less than $1,000. When you do the calculations, you should see less than $1,000. So the bond value should be less than $1,000, and we would call such bond a discount bond. Okay, then another thing that's important is the 8% coupon rate. So 11% yield to maturity is 11% discount rate per year. What does 8% coupon rate mean? It's only good for finding the dollar amount of the regular repeating payment on the bond, which we call coupon payment. So coupon payment is equal to, we take 8% coupon rate multiplied by $1,000, and we get $80 per year, right? An $80 coupon amount. So that's two things that you could right away figure out. Okay, well, we actually want to do two sets of calculations. What if the coupon payments are paid annually, once a year? And what if instead they are paid semi-annually, which is how it normally is in real life? What's the difference? The difference is, let's say we are looking at the annual coupons, year 0, which is today, year 1, year 2, and so on, all the way to year 10, which is the maturity date, 10 years from today. 10 years from today, the investor will receive the last payment on the bond that he purchased from the company. Okay, so the $80 coupon payment is what the company will be paying every year back to the investor. And the $1,000 face value, the additional dollar amount that we are given, is another thing that the company will pay back to the investor at the very, very end when the bond matures. With semi-annual coupons, things are a little bit different, because essentially we are saying that there are 2 coupon payments made over each year. Okay, so we need to split each year into 2 halves, 6 months, another 6 months. And what we are doing is we are splitting the annual coupon amount into two halves as well. So after the first half a year, the company pays to the investor $40. After the second half a year, another $40. Altogether, we give the $80 coupon payment for the year. And that will continue until the end. So at the end of year 10, the company will pay back the last $40 semi-annual coupon amount plus the usual $1,000 face value, right? So this is the difference. And this slight difference will actually affect our calculations quite a bit. So to find the bond value, we need to enter the future value, the payment amount, the number of payments, and the interest rate. And that will allow us to compute the bond value, compute PV. So we enter these four things, whether we need to work with annual coupons or semi-annual coupons. How do we enter the numbers correctly? With the annual coupons, the future value is 1,000. We set it to a negative value. The payment is 80. We also set it to a negative value. And it's important that everything that's in the future, which is both the face value and the payment, the coupons, are entered with the same sign. And how many payments? We have one per year over the next 10 years, so we put 10. IY is the discount rate, that's 11%, it's given. In the second case, it's the same future value, $1,000. The payment, however, is now half of the annual coupon payment, which is now 40. And once again, we need to be consistent with the signs for all the cash flows that are occurring in the future. The number of coupon payments is double the number of years, 20, right? So why is it 20? Because we have 10 years and we multiply that by 2. 2 coupon payments made every year. And we also make an adjustment to the discount rate, the IY, which should also reflect the semi-annual frequency. So if it's 11% per year, then for half a year, that will be 5.5%. So we got 5.5% by taking 11% per year and dividing that by 2. And also the $40 payment was $80 per year divided by 2. So these are the three adjustments we have to make when we are working with semi-annual coupon payments. And now let's calculate everything. Annual payments. We enter 1,000 negative FV. We also enter 80 negative PMT, 10 N, 11 IY, compute present value, $823.32. So the present value equals $823.32. In the second case, with the semi-annual coupons, let's clear everything. I press second plus minus to reset it and then enter. With the semi-annual coupons, only the future value, the face value, remains unchanged. So 1,000 negative FV. Then my payment is now only 40. I press 40 negative PMT. We have 20 of those, 20 N. The discount rate IY per year is only half of 11% yield to maturity. So I press 5.5 IY and compute PV. And we get a slightly smaller number, $820.74. So the present value in this case is $820.74. And it is a slightly smaller answer because of the heavier discounting. We discount things kind of more, in a way, more often. And with the whole time value of money and interest on interest considered, we get a slightly smaller bond value. And both numbers we got are below $1,000, which makes both what we call coupon bonds.